Hi folks, so in this video what I'm going to be doing is going over the Section A problems from the 2021 Leaving Cert DCG higher level paper. As with any questions in the Section A section, there's always going to be 4 problems posed at you, and what you're going to have to do is you're going to have to attempt 3 to try and get the full marks out of it. So in these questions I'm going to go from A1 to A2 to A3 to A4, starting with this one up here. So I'm going to zoom in on that one there now. And this question here is based on the topic around perspective drawing. Okay, so it says here, just make sure I fill it fully in the screen. There we go. The 3D graphic shows a boxing ring with steps, and you can see the 3D graphic here. Shown below is an incomplete perspective drawing of the ring and steps. The positions of the ground line and the vanishing points are already given. So they've given us the ground line here, and they've given us the horizon line, which is where the vanishing points would be. Part A, complete the perspective drawing of the boxing ring. So we have to complete this, and they've kind of given us this guy here. And then it says part B, the steps are of equal height. So we focus on the boxing ring first. Part B, the steps are of equal height. Complete the perspective drawing of the steps. So, as any time with perspective, what we want to do is we're given 2 vanishing points. All lines that are running in this direction parallel with this face of the object, okay, are going to vanish to VP1, and any lines that are going parallel with this face of the object, the boxing ring, which is like, if you think of it, I suppose the ropes on the kind of inside the boxing ring as well, will all vanish to VP2. Okay, so first of all, to start completing the drawing, I'm just going to start off by heaving in some bit of information. Just because they've kind of given us the shape here, you can see they've got left kind of the construction lines which are being red. I am going to heavy in those. Lots of students might accidentally leave out marks here, and I'll just put in that one as far as there, because there's no heavy line inside here, and likewise with this one as well. So just using lines there, heavy in what they've given you. Okay, silly marks to lose out on if you were to leave those behind. Okay, so there we have, we've heavied in the boxing ring. Now what we have to do is we're going to have to get in these, the rope section. Okay, now, essentially, okay, I'm going to get 3 or 4 ropes here. You can see the outside ropes, but the hard part of this one is, I suppose, figuring out, you've kind of got the pole here, you have another little bit of a pole inside there that we're going to have to get. Now I'm going to focus on those 2 kind of pole sections first. So, firstly, I just recognize that they are going vertical. So from this line here, and you can see it's in line with the edge, so it has to be in line here as well. So this is the one I'm trying to find. Okay, so I'm going to just project up a light line, and somewhere up along that light line is going to be the top of it. Now the easiest way to find the top would be from, I'm going to go VP2 here. It doesn't matter if I do VP2 or VP1. I'll actually go VP1. From this point here, because it has to be at the same height all the way around, I'm going to go VP1 to that, but extend it across. Okay, and you can see there now it's kind of gone into this line here, so it's like it goes up as far as there. So that means I'm going to heavy that line up to there. Okay, because I have to be at the same height as this pole here, so I'm after vanishing through that point, and it comes up to here. Now what I want to find is this one. Okay, so I'm going to do the exact same thing. Now to find that one, from VP1, I'm going to go through this point here. Accurate. And a good sharp pencil for this, and I'll do the exact same with this one. Now that one looks like it's already gone through it. If you follow this one, it's gone through it there, but I'm actually looking for this point, actually, sorry, I should say. I need that one as well. So somewhere along that line there, and somewhere along this line here is going to be that point. Now I only need 1 point, so what I'm going to do is from VP2, I'm going to vanish through the bottom one of this one. Once I have the bottom one, I technically can do my line. Vanish through. You can see that point right there where the 2 of them meet. I'm now going to do a vertical line up like that. And there we have it. There's the 2 little kind of vertical stanchion poles. Now I'm going to get the lines running across. So at the bottom line, that's a heavy line anyway. Okay, then this one, I'm going to vanish through it. There's the second. Now I'm going on to the third. And finally the fourth. There we go. And now that I've got all those kind of rope sections in, now I'm just going to simply connect them up here. Really easy. The first one was kind of already done for me. This point here will connect to that one. Heavy them in. No need to vanish it fully back. And there's this one will connect to here. Yep. Okay, there's the ropes done. Now I have to find the ones that are going to connect over here, like those ones. So to find those points, I'm just simply going to vanish. I think this is the most accurate one. So there'll be a point there. That one will connect to the bottom. Then I'm on to the next one. Finish it out all the way along. There's that point. That'll connect up to the next one. Then I'm on to the third one. And that point there, it'll go up to the third one. And then finally, the fourth one. And from that point there, it'll connect out to here. Okay, there we have it. We have now completed part A of the drawing. We've completed the perspective drawing of the boxing ring. Now we're on to part B. It says, the steps are of equal height. Complete the perspective drawing of the steps. Now, the only way we can actually do this, okay, you can see they've kind of given us a diagonal line here to represent the drawing, but that's only going to show us how far the steps go down as. But the steps are of equal height. Now, essentially, this line here, in reality, is the same height as this line. But based on our perspective drawing, as the object vanished back, it appears that it's smaller, because the further it goes away, the smaller it's going to appear. But in reality, that line there is the same height as this line. Now what I'm going to do is, because that is the overall height of our steps from the top of the steps down to the ground, I'm going to divide this line into 3. So what I'm going to do is do a line off at any random angle. I'm going to do 3 equal measurements of 10. Just using 10. It's easy. 10, 20, 30. From the last point, this normal junior cert graphics here. I'm going to connect that one up and then use sliding set squares from the other 2 points to divide my line into 3 equal sections. There's one, and there's the second. Now I've split that line, that point there, and that point there. I've that line broken up into 3 equal heights. Now I'm going to vanish those 2 points all the way back to BP1. What that will help me do then, okay, is it's going to break this line into 3. There's section 1, section 2, section 3. So that's the height of the top step, that's the height of the middle, and that's the height of the bottom. Now, if I vanish to VP2, that'll show me, if I vanish through those, that'll show me where those are actually going to meet. So by vanishing through VP2, I can now go and we'll see what my accuracy is like. Yeah, it's pretty good. I'm happy with that. So there's the first step. The second step will be where this one goes through the diagonal line. And the third step is here. Okay, simply a case now of just heavying in that little section. And obviously then we have to make it 3D. So all these points here now will vanish to VP1. It's just a case of following the sequence after that. So all to VP1. And I think I've this one here as well. Now, because they've all vanished, I'm going to drop down this one here until it's hitting that face. I can now heavy in this one to there. And from that point right there, it'll go through to VP2. I can start building face by face. And from there, it goes vertically down. There we have it. And then, once again, VP2 all the way out to there. Vertical line. And heavy these in. Okay, there we have it. That there is part B done. The steps are of equal height. Complete the perspective drawing of the steps. Part B of the drawing done. A little bit tricky, just kind of in the accuracy in that question, okay? So very important, you have a good sharp pencil, okay? Mine's gone a little bit blunt now, but a good sharp 2H pencil and you should be absolutely fine. Now what we're going to do is we're going to move on down to section A2. So, this question here, it says the image below shows the Spinnaker Tower in Portsmouth in the UK. The design includes 2 hyperbolas. It says here the drawing on the right shows the axis AA1, so we've got an axis line AA1. It also gives us the directrix DD1. It gives us the focus here and eccentricity line E of the similar hyperbola. That is our line from of the eccentricity where the axis cuts the directrix. You start from there, that'll give us your eccentricity line. 2 points on the curve are also given. They've given us a point P and a point directly above the focus where it hits the line of eccentricity is also a point. that line there would be called the latus rectum. Part A, locate the vertex and 5 additional points on the curve and draw the top portion. We only have to draw the top portion of the parabola. Part B, draw the tangent to the curve at point P. Okay, so what we're going to do is, first of all, locate the vertex. It tells us what to do. To find the vertex, all we do is, from the focus, we go 45 degrees to our axis line to hit the line of eccentricity. Where it hits the line of eccentricity, we drop that perpendicular down to the axis. Technically, right there, that is our vertex. Never ever changes. Now, they've actually asked us to find 5 additional points, and they've already done the kind of sections for us to find it. So all I'm going to do is, where every one of these, okay, went up, and you can see they've already brought it, but from that point right there where it hits the line of eccentricity, I'm going to drop it down. Where this one hits the line of eccentricity, I'm going to drop it down. And where this one hits the line of eccentricity, I'm going to drop it down. Likewise, at the opposite side, where it hit the line of eccentricity, drop it down, and drop it down. Now, all we're going to use here now is our compass to be able to help us find additional points on our hyperbolic curve. So using the focus as your center point, what you're going to do is, for every additional height, you can see this is the first one here. So where that one goes across and hits the line of eccentricity and drops down, somewhere along that line there is going to be a point on my hyperbolic curve. So I'm going to put my compass onto this point here. And where it cuts the latus rectum line, I'm going to rotate it. And where it cuts through the vertical line, that there is a point on my hyperbolic curve. Now I just have to repeat that sequence for the other couple of sections. Okay, so what we're going to do is, using the focus point again, I'm going to go up to the next one, which is up at this height, and that's going to cut this vertical line, the second one in. So from there, there's my second one, mark the point. And then finally up to the third one, on this side, it's just about inside. As you can see, it's just gone in, it's just inside the line of eccentricity right there. The next point they've already given to us. Now when we get up to this side of it, I'm just going to rotate to the right instead of to the left. So from here, there we go. So it's after, once again, it's after going quite close to it. There's that one. Then up to the next one. Further away you get, should get a little bit further away. There we go. Okay, have we found 5 additional points? Yes, we have. 1, 2, 3, 4, 5. So now what I do is simply, including the vertex, I suppose technically I found 6. I'm now going to sketch in a curve as best I can going through those 2 points. And that curve will be my hyperbolic curve. Okay, I'm going to switch over to HB pencil here just to try and make it a little bit darker. Okay, so there is my hyperbolic curve. They only asked us to do the top portion. If it was the opposite side, you could use axial symmetry to figure out the bottom half of it. Now, what we want to do, that's part A done. Part B, draw a tangent to the curve at point P. Now, the easiest way to do this is, from P, you're going to connect it to the focus, okay? And I want the tangent to go through that, okay, to go through point P. Now, we know a tangent is a line that touches the curve at one point. They've technically given us the point. What we need to do now is find another point out somewhere on that tangent line to be able to draw it. So, the way to do that is, you connect P to the focus, okay, and perpendicular, you create a line perpendicular to that line to hit the directrix line. So, perpendicular to this line here, that you've just done, you want to go perpendicular to that line there, through the focus in the opposite direction. That angle in there is 90 degrees, is perpendicular, and that point right there where it hits the directrix line, that is another point that is on our tangent line. So now that I got this point which is on my tangent and this one, I can simply connect them up and I can draw on my tangent. And there is our tangent. Part B of the question done. Okay, nice handy question, especially when you understand the area around conics. Okay, that was simply just drawing a hyperbolic curve and then getting a tangent when they had given us the point P. Sometimes in a question, instead of P being on the curve, sometimes P will be here, let's say at this point, and all you do is you connect P to the focus and then you just go perpendicular the other way to cut through the curve. Okay, so that's A2 done there, guys. Now we're going to move on to the top right of the page and we're going to go on to question A3. So rotate this up here. make sure it's nice and even in my screen there. Okay, a little bit bigger. Right. Question A3. It says the image below shows an ammonium ion which has the shape of a regular tetrahedron. Now we know a regular tetrahedron is a four-sided solid where all the sides of it are triangles and equilateral triangles. It says here a nitrogen atom is located at the center of the tetrahedron and 4 hydrogen atoms are located at the vertices. So 1, 2, 3, 4 on the outside points. In this case, they are A, B, C, and D. A is at the top, the apex. B, C, and D are all on the ground. They are the hydrogen atoms, and we have the nitrogen atom. I think they say, yeah, nitrogen atom in here, and it obviously has a little height. It goes up into it. What we have to do is the drawing shows the projections of a regular, A, B, C, D, and a center N. Part A. Determine the dihedral angle between the planes ABC and ABD. So what they're asking here is we want to get the dihedral angles between two planes. I'm just going to use a little bit of color here. We want the plane ABC, so I'm just going to check that, which is this one here. You know, just going to use red on the outside. So there's that plane, the red plane, which is ABC, and I'm going to use a blue for the other one, ABD, which is this plane here. I'm just going over it as best I can. Okay, so I need the dihedral angle between the two of those. So step number 1, when you're getting the dihedral angle, which is essentially the angle between two surfaces, ABC and ABD, I need to see those surfaces as edge views. Okay, so first of all, identify which is the common line between them. That is the line AB in this case. Now, I didn't have it in elevation. I probably should have, but I'll come back to it and do it. So the line AB is our line of intersection. Now that we've identified our line of intersection, I need to see that line of intersection as a true length. Is it a true length in elevation? No, because the line AB in plan is not parallel to the XY line. Because it's not parallel to the principal plane of reference, therefore in elevation it's not a true length. And in plan, it's also not a true length because in elevation, AB is not parallel to the XY line. So the only way I can see that as a true length is when I do an auxiliary view and I'm going to look perpendicular to it. Now, I'm just looking at this here. Yeah, so I'm going to be looking in this direction. So the direction of the arrow. Okay, I'm going to look perpendicular to that. So I'm going to set up an X1, Y1 parallel to my line AB because that's the only way I can look perpendicular to it. So parallel to the AB line, I'm going to set up what's known as my X1, Y1. I'm going to project out perpendicular. So D and C will come out, B, and it's gone slightly off the screen there, and A. Okay, I'm going to have to extend down my X1, Y1 a little bit further. Okay, now, first thing to note, we project from the plan, we take our heights from the elevation. Good thing is, the 3 points D, B, and C, or B, C, and D, are all on the ground. So look, there's B. So where it comes out onto the X1, Y1, that would now be known as B1. C and D are here. So I'm seeing those 2 points as a point view. C1, comma, D1. Now, the only one I have to take the vertical height for is A. So now I'm going to connect A down to A in plan, just to make sure I can take the exact height. I'm going to take the height, project from the plan, take your heights from the elevation. There's A. And now I'm going to follow A out onto my X1, Y1 and mark it up. So, I'm going to connect A now. So I've got a plane ABC, which I do see. So I'm going to connect that up. And there is A1 connected to C1. So there we have it, plane ABC, but I've also got the plane when I'm looking in this direction. The plane I see first is ABC, the plane hidden behind it is the plane ABD. So I've already drawn that as well, but technically the line from A to D would be hidden detail. Now we can't see it because the line from A to C is heavied in. Okay, so technically the plane that I'm seeing, as I said there, is kind of the red plane. The blue one is the one that is hidden behind it. Doesn't mean it's not there, it's just hidden behind it. So let's go over these now. So it's the same thing here. I had the plane ABC. So there's the one ABC in elevation. I also had the plane ABD, which is this one here. Okay. So there's the plane ABD. Now, what's helpful here is technically the line I have AB, this line here, is a true length. Mark it TL. Because I've looked perpendicular to it, and I've taken my heights from the elevation, this line now is a true length. And any time I look along a true length, I will then see that point, or that line there as a point view. Very similar to CD, because we looked along the line CD here. We're actually looking perpendicular to this line AB, but it just so happened to be that this line CD was a true length that was perpendicular to that line, so therefore I saw CD as a point view. Now what I need to see is, because this is the line of intersection, I've got the true length of that, I need to look along that and see AB as a point view. So I'm going to set up what's known now as an X2Y2. And the X2Y2 will be perpendicular to the line AB, or A1B1. So keep it quite close. Keep the drawing neat and tidy. And now I'm going to project out my points. So AB will come out here. I'll bring it out a little bit further. And then CD will also come out. Okay, now that there is my X2, Y2. All I do here is, when we projected from the plan, we took our heights from the elevation. Now we're projecting from the X1, Y1, we're onto the X2, Y2, but we take our distances from the X1, Y1 back. So the first one I'm going to take is the distance from the X1, Y1 back to B. And just to recognize that is the same distance as the X1, Y1 back to A. Therefore, I'm going to see AB as a point view, because both of them share the same position. So this here now is a point view of the line of intersection, that is A2, B2. Now I'm going to take the distances back for C and D. So if I want to find C, there's the distance back to C. Mark it out from C1 here onto the X2, Y2. So that is C2. And now I'm going to take the distance back to D. When it gets quite small here, you just want to be 100% accurate. There we go. I'm going to mark it out here. There we go. That there is D2. Now, I want to draw on the plane ABC. AB, same position, so that's the same. That's one line AB, but I'm seeing it as a point. And now I'm going to connect A to C and B to C. So now, technically, that face there, ABC, which is the red face, I'll put it in now. This time I'll use my marker. I'm seeing that face as an edge. What I mean by that is I'm seeing it as a line. Now I'm going to heavy in the face ABD. A to B, B to D, D back to A. Once again, this is the blue face. I'm also seeing it as an edge view. Okay, but what's important about that is those two faces, the red and the blue face, I'm now seeing the angle between those. That angle inside there is my dihedral angle. Okay, that method will never ever change. Identify the line of intersection. Make sure you find it as a true length if it's not already one, and then look along the true length, and those two other points then will give you edge views of those surfaces where you will see the dihedral angle between those. Usually you will come along then and measure that angle with your protractor. Okay, part A done. Part B, determine the true angle between the lines BN and CN. Okay, just got to rub out this little arrow I had here. Bear with me. Okay, because I think we might be drawn in here in a second. So BN and CN. So there's a couple of ways you could go about this. Essentially what they're saying is I want the angle of this guy inside there. What is that angle inside there? And in the plan view, probably it's that angle. Now, in either view, I don't see the true shape of the triangle BCN. Okay, so I can't actually just say that that is the true angle. It is not. There's two ways we can go about this. The way I'm going to do it is by a rebatment method, and I'm going to see the surface BCN, that triangle, I'm going to see it as an edge view, or so I will, and then I'll rebat it onto the ground. The other way then would be to identify true lengths. That's probably actually a quicker way now that I think of it. BC, because I have that as a true length, it's on the ground, and I just need to know that this are the true length of the line from C to N, because they'll be the same distance, because once I have the true length of the line C to N, that'll be the same as the line from B to N. So that's probably one way I could actually go about it. C to N and treat it. Yeah, okay, I'll actually do the rebatment method first, and then I'll show you the true shape method, okay? So, first of all, I'm just trying to see the surface BCN as an edge view. Now, what's helpful here is the line BC is a true length, because B and C are on the ground. Okay, BC is parallel with the XY line, it's sitting on the XY line. BC is a true length. So if I look along BC, I set up an X1, Y1, it's just another auxiliary view. I'm going to set up an X1, Y1, I'm looking along it. Okay, I'm going to set up an to about here. I think that'll be okay. That's my x1, y1. Now what's helpful there is, I'm going to project up n as well, because that's the other point I want. What's helpful with this is B and C are on the ground, so technically I don't have any heights for them. They're resting on the ground, so this now is B1, C1. But I'm seeing BC, that line, I'm seeing them in the same position. That's a point view. Now, because I project from the plan, I'm going to take my heights from the elevation, B up to n. Make sure I have the right height there. There we go. And I mark it from where n projected out onto the x1, y1, mark it out. And what I'm seeing here now, BCN, I'm now seeing n, I'm going to call it n1, okay? That triangle, okay, BCN, so I was just going to use a bit of color here now. Go to green now. That triangle, okay, which is this triangle here, that whole triangle, I'm seeing it now as an edge view. Now what's helpful about that is I can now rotate that around. I can rabat the point n around, because the x1, y1 is representing my ground, because this is an auxiliary elevation. So I projected from the plan, I took my heights from the elevation. I'm going to rabat n around, and I basically rotated n until it is in its new position here on the ground, and then I can take it back. And perpendicular then, project n out, I can now say, if I connect n to B and n to C, that angle inside there is the angle I want, which is determine the true angle. I'm just going to write in true angle BN to CN. The true angle between the line, because this would be the new position of n. So BN to CN, that is the true angle inside there. Okay. The other way, as I said, it could have been done, and I would have ended up finding this point as well, if I just got the true length, and this is probably a slightly quicker way, some students mightn't recognize this. I just needed to find the true length of the line from C to N. So if I treat C as the apex of a cone that has been inverted, okay, all I'm going to do is I'm going to rotate, bring up that line there like that, and what I'm going to do in my plan view, if C is the apex upside down, when we look down on top of a cone, we will see a circle. So I'm going to rotate N in plan, okay, until N has rotated up until it is up here in this position. And what you can recognize is if this is the new position of N, okay, that's the new position of N, that line there from C to N is now parallel with the XY line, but by bringing it up, technically the new position of N would be here in elevation, and if I connected that over there, that line that I've just drawn there would be a true length. You could take that distance on your compass, that distance, and from C, mark it off. You can see there, pretty close, a little bit of inaccuracy, but that would be technically the other method of how you could find it. Okay, so that there is C3 or A3, guys. Now we're going to move on down to the bottom of the page and we're going to do A4. Okay, so A4, let's bring it down here so it fits nice and neatly in the screen. Just going to zoom out a little bit there and hopefully that's all just about fitting in our page. Yeah, okay, so just to complete these questions here now. Last question on the page from 2021. It says here, the image below shows a modern house design which is based on intersecting prisms. The drawing shows the plan and incomplete elevation of a similar structure which includes a pentagonal prism intersected by a truncated rectangular prism. A pictorial view of the intersecting solids is given. We've got that. Part A, complete the elevation showing all lines of interpenetration, and part B, determine the true shape of surface A. Okay, so we're going to get the lines of interpenetration first. What they're basically saying is where this kind of solid is intersecting the pentagonal prism, we're going to find these kind of like lines of intersection here, where they're kind of cutting up, okay? So we have to find those. Now, they've technically already given us one line, which is the one we don't see on the pictorial. They've given us this one. We have to find, let's say, where this one is, okay? Now, there's multiple cut points on this object. If we break down the faces, there'll be a cut point here. So let's say I'm going to label them actually. I'm just going to label them numbers. I'm going to say this is 1. Then the next one will be to this one. That will be 2. Now 2 then, because that's the face, if you think of this face up here, so there'll be a point up here somewhere. It's probably in there somewhere where that line will come down. Let's say that's number 1, and then 2 is in there, so it'll go down like that, and then 2 goes all the way down to the ground. There's probably a 3 down there. Okay, now so there's 2, and it goes down to here. There's 3, and it comes all the way out to the edge. Now there's not a cut point there, so that's fine. That's just a straight edge, and there'll be a cut point then on the ground as well. Number 4. 4 will connect up. There's number 4 up to 5. There's number 5. 5 will then connect up to 6. So 4 and 6 actually has 2. 4 has 2 of them. Apologies. Should have identified that. So I'm going to say 4 comma 6 there, and then there'll be a point up here, 7. There'll be a point here, 8, and a point here, 9. So I have to find kind of 9 points. Okay. Now the first one I can recognize, this line out here is a heavy line. Just zoom out a little bit there. So that one there, I'm just going to heavy in fully. Okay, and they've already identified 1 to us. They've already found number 2 and number 3. So 3 is found, 2 is found. Okay, I am going to, there's no hidden detail in there. So there's a point number 4 here, which is on the ground, I said. So watch, if I project up 4 on that line. Now I found number 4. Number 5 or number 6 then, and number 5 are the ones I want to find. Okay, so we'll start with number 1. So if you watch here, number 1, okay, that's the one you can see I've kind of identified where it is on that face in there. Now what we're going to do here is we're going to take a horizontal cut across the top of it. So a horizontal cutting section. So what would that look like then in the plan view? It would be a line running across it. But what's helpful here is this line here is inclined, and we can see that face. I can now identify that point there somewhere up along here. So by doing a horizontal cut, project that up to my elevation. I've now found this point. So how do I find that then? Somewhere along this line, if I draw the line back, and do a line across, okay, somewhere along that line is going to be point number 1. How do I find point number 1? Project it up, and it's in line there. So there we have it. Right there is point number 1. So now I can start to heavy this down, and I know point number 1 connects to number 2. Okay, so I've kind of got that side face there done. Fantastic. Now 3 goes around to here, then okay, that one's done, I didn't label it, but then that connects to 4. Now 4 connects to 5. How do I find 5? 5 is on the outside, so simply just bring it up, and then it's on the same line as where 2 was, so bring this in. Okay, and once again, I'm going to label that. There's 5, and we know 4 connects to 5. Now, building it up, I have to find technically 6, okay, which is on the same line as 4. Now 6 here is on this line, so if you follow 6, that's where it kind of came to the side of it. Using a horizontal cut, that'll go up, or hits that line there. Now going to go across. That there is 6. Okay, now I know 5 connects to 6. And that there is kind of the front of my object. Okay, that there is the front of it. Now everything from this point now, 6 going up to 7, is all going to be in hidden detail. 7 is right at the top, it's on the ridge, and 9 is at the top, so I'm going to project up to both of those. So 9 will be up there somewhere, 7 will be up there somewhere, and all I'm going to do with those is project a line across and a line across. So there's 7, and there's 9, 9, and 7, and the last one I want to find is 8. So same thing with 8, line across horizontal, where it hits that face. This time it's on the back edge, it's over there. Okay, and somewhere along that, once I project it across, it's going to be 8. Project it up. There we go, and there's 8. Right, so draw that in now. I know 6 connects to 7, but because I can't see it, I'm going to put it in as hidden detail, and the edge here would run in as hidden detail. Okay, I'm going to do the same with 9. Now this is the bit that's important. 7 will then connect down to 8. Once again, I don't see it, so I put it in as hidden detail. And then that edge should go down there as hidden detail. And then 8 connects to 9. Same thing, hidden detail. Okay, and 9 connects back to 1. Once again, hidden detail. Okay, and there we have it. That is where the two solids are intersecting one another. Okay, a little bit of a tricky one there, just kind of figuring out the hidden detail element of it. So that's the part A of it done. Now what we're going to do is the part B. It says determine the true shape of the surface A. So just thinking here now, can I do a rebatment method? I need to see that surface A as a true shape, so yeah, I'll have to get it and I'll rebat it down. Okay. Okay, if I break up surface A, and I'm going to break it into letters this time, I'm going to say, now this point here, there's surface A. I'll shade it in first, just using my highlighter here. So that's the surface we want. I know there's 2 points on it already called 2 and 3. Okay, but I'm just going to rename those, repurpose those. I'm going to say this is A, this is B, this is C, and this is D. So I got a surface. I want surface A made up of A, B, C, and D. Now if I find those, okay, the 2 top points would be out here. That would be A and D. So there is A, there is D, and then down at the bottom I've got B and C. Now, are any of those true lengths? Yes, they are. There are true lengths in elevation and plan. But in the plan, I want to basically look along the line BC because that's on the ground. Okay, so I'm going to set up a line like that. And because the line is horizontal, I'm going to set up an auxiliary. This here is now called my X1, Y1. Okay, and essentially B and C are on the ground. So project from the plan, take your heights from the elevation. B and C are on the ground. So this here now is technically B1, comma C1. Okay, and I now need to find A and D. And what I'm going to end up doing is seeing this surface as an edge view. So I'm going to take my heights. I can find my compass there for the elevation. This is very similar to the last question where we're going to rebat it. See the true shape. So took the height from C up to D. That's it, or the ground XY line up to D. So there we have, there is A1, comma D1. Now if I connect those, I'm now seeing that surface. Okay, I'm now seeing that surface as an edge view. That red surface, that's why I've just kind of gone over it in red there, but I'm seeing that as a true length. Now all I'm going to do is B and C are on the ground. I'm going to imagine, because they're on the ground, I'm just going to simply rebat this one down. X1, Y1 is representing our ground. Now rotate A and D down. A1, D1 have simply come down to here into their new position. I rotate it around A1, comma D1. Okay, and then if I project them back, somewhere along that line is A and D. Bring D out, bring A out. Okay, and there we have it. There's the true shape. C connects to D. And remember, our new position for D is here. And our new position for A is here. Just mark it there. D connects to A. And like in the drawing, A connects to B. So here's B. Okay, there we have it. I just maybe did that then as well. There we have it. That is our true shape of surface A. Okay, and there's a slight difference in regards to the size of it. All I've done is I've folded it down onto the ground. It might look very similar to this one, but there will be a slight discrepancy. Okay, there is our true shape of surface A. Alright, so just zooming out there, guys. I'll just come back here, get that right into the middle of the screen. So there you have it, folks. Nice kind of couple of questions there, okay. This one probably easy, then next, I suppose this, in my opinion, would be the easiest, then this one. couple of bit of understanding in these ones here, and they were really challenging you in regards to the rabattment method there. Look, the same method we did here to get the kind of the true angle, which would obviously give us the true shape, and likewise here we did the same thing where we rabatted the surface down to get the true shape of it as well. Okay, multiple ways you can go about the answer to these questions, guys, but obviously it just comes down to your own understanding. Okay, so that there, guys, was the 2021 Leaving Cert Section A short answer questions for the higher level paper. Hope you found that helpful. Okay.